Today's video titled TV-7 Tube Tester Calibration and Service, a Practical Guide. Doing this in response to many requests that I have received. Okay, a special warning here. There are high voltages present when working on a TV-7. You will have to have the unit outside of its case in order to calibrate it. Thus, you will be working around high voltages. If you're not trained or comfortable working around such voltages, please seek professional help in calibrating and or servicing your unit. All right, a few disclaimers before we dive in. First off, I am not a TV-7 expert. I'm just somebody that's been around tube testers their whole lives. I've worked on quite a few of them, including many TV-7s. I don't do this for a living. It is just a hobby. Second up, I'm sure people will debate what I put in this document and or YouTube video. Reason so, there are many ways to go about these calibrations, and I'm not saying any of them are any better than the other. And I do not have claimed to have invented any of these practices. Most of them are pretty logical and they make sense. I'm just claiming to have laid them out in a way that hopefully you can easily understand. I would say most of what I'm sharing in this video can be found on the web. Sometimes it's just in long, convoluted explanations, and I'm trying to break it down and make it simple for you. And I would say these steps are not all-inclusive. They assume your unit is in somewhat decent condition. In other words, it doesn't have a bad transformer or maybe a broken meter or worn out pots or burnt switches, or that someone's been in there soldering and changing wires around in the past. If you find a unit that's in that kind of shape, you probably need more help than this video would provide you, so you'll want to seek some professional help. And speaking of professional help, there are some experts out there. Daniel Nielsen, he's helped me out a few times over the years. He's kind of the renowned expert, and he's a good source for parts as well. A guy named Roger Waters, kind of known as the Hickok Doc. Roger Kinney at All Tube Testers. I bought meters and various things off of him over time, and he does calibrations as well. There's this ham radio guy, EB5AGV. He has a page just dedicated to the TV-7 tube tester, and there's a lot of good information on there, as well as tube data sets. So if you're looking for a nice spreadsheet or something with all the tube data sets, it's on there. And there are others, so just take all that for what it's worth. Okay, I thought it'd be worth talking a few minutes about what the TV-7 is and what it's not. These things came around somewhere in the early 1960s, because the first military manual for these popped up in June 1960. They were made by several different manufacturers to the specifications that the military had. Hickok, Four-Way, Stark, Supreme, others made them. And they all seem to be very similar quality. So if you're searching out one made by one company versus another, I don't think you're going to find a big difference in the quality there. They are extremely rugged devices. The cases sometimes can be beat to death, and then you open them up and the tube tester on the inside looks beautiful. There are 5 different variants of this: the TV-7U, the AU, the BU, the CU, and the DU. A couple variations along the line. The 7U, the very first one, you can see a picture here. They had these skirted dials for the bias and short function, so it's easy to identify those. One downside to these, they use these phonic wafers, and they're a little more prone to warping than later models. They use ceramic wafers. They also use fixed resistors, not potentiometers, so much more difficult to calibrate. I'm not saying you shouldn't get one, I just wouldn't pay near as much for one of those. And then on the other end of the spectrum, you've got the DU, which is kind of considered the Cadillac. Although I will say that the CU and BUs are pretty much just as good. And the reason being, the DU added a high conductance range for high mu tubes. It's not used that often. But one beauty of it, even the C and D, they have a full set of adjustable potentiometers for calibration. And the later models like the C and the D, and maybe the B, I'm not 100% sure. I don't have one in the shop right now to compare to. But they added ferrite beads to all the tube sockets to prevent oscillation. So, get you a CU or DU if you can find one, maybe a BU. You'll be in good shape. Okay, one thing to note about the TV-7, it shows your GM readings on a 1 to 120 scale. And you can get a spreadsheet that matches GM values to that, so you could sit here and compare. Gets a little clunky in doing that. You can also replace your meter with a modern version that has a GM scale built in it. Here's an example of a meter face that I got from All Tube Testers at one point in time. And I know Daniel Nilsson also has a version. The TV-7 uses a 5-volt signal test on scales B and C, 1 volt on D, and 0.5 on E. That is the grid signal that it's feeding into these things. The shunt pot only gets used for testing rectifier tubes. Some of the pros of the TV-7s, there are many of them out there. Thus, you can get parts for them. They're quick and easy to use. I will say this, it is my go-to tube tester. I've had everything from Amplexes. I've got one of the really nice computerized Western Electrics right now. I've got lots of others, and my favorite go-to tester is the TV-7. The reason for that, it is just super simple to use. It gives really good, accurate readings, and they're portable. You know, if I need to grab it and go over to, going to look to buy a bunch of tubes off somebody, I may take it along with me. They're easy to find someone to calibrate and or service. They have good value recognition from a tube standpoint. So in other words, if you're posting tubes for sale on eBay and in your subject line you put TV-7 tube, tested or whatnot, people look at that tube and go, it's been tested by a TV-7. I can rely on what this thing is telling me. I'll say that good or bad. That's what I've noticed. And people have built spreadsheets with lots of newer updated tube types in it. So easy to find out there. All right, a couple cons of the TV-7. First off, they are not a laboratory tube tester. And yes, I'm saying these are not the best tube testers out there. If you had to choose between this and say an Amplexus or the computerized Cardomatic Western Electric or something, or maybe a triplet 3444 or a Hickok 539B or C, I would tell you those other units are much more precise and have more settings and calibrations and would be a higher end laboratory tube tester. On the flip side, I think these are pretty rock solid, and for just testing out tubes and good all around bench use, they're one of my favorites, as I mentioned. These things were made to be carried out into the field. These were a field tube tester. They, back on the back of some military truck, drove out to a military camp somewhere, and they've got some piece of equipment not working properly. They pull this thing out and test the tubes in it. It's what it was designed for. There's this thing here I would call calibration creep, and you can have this with any tube testers. But I'll give you an example. Let's say I bought a set of calibration tubes for someone and I tested this tube tester that we're going to do today. And then the individual that owns this tube tester makes a set of calibration tubes, and then they give those to someone else and they test them. And so on down the line. Well, you're losing a little bit of accuracy all along the way, and you don't know if you're ever as accurate as all the way back to when the original calibration tubes were made. So you'll have some of that. And the cons again are that 1 to 120 scale, which just kind of gives you a relevance of how good a tube is and doesn't necessarily match it to a GM rating. Just thought I'd spend a minute on the basics of how a TV-7 works. It's basically a classic Hickok circuit design. You can see it up here on the wall in front of this individual here. It's a variation of a Wheatstone bridge kind of layout here, and just classic Hickok design. In other words, most of the Hickok tube testers, whether you're talking a 539 or a 600 or 6000 whatnot, they all use this basic circuit. As you can see here, here's the schematic for a TV-7, and there's that picture that was on the wall in front of that guy. Well, this little circuit I'm showing you right here is basically the exact same circuit that you saw up there. And finally, a couple things about this. So you have this 83 rectifier tube in this thing, and you're kind of taking the rectification coming off of it, high voltage, and feeding it into the tube under test here. And coming off the other side of the tube on test, you feed into that kind of little Wheatstone bridge layout. And then you're actually modulating the grid of this tube, and the range switch here, you can see E, D, B, C kind of changes between these voltages. And you can see what some of the modulation looks like being fed into this thing. And the grid bias little potentiometer you use adjusts that amount up or down. So once you set the range and you kind of set your grid bias and you set all the specifics of the tube, you know, filament voltages, which pins are the screen, the grid, etc., then it kind of measures the tube using this Wheatstone bridge here against all those settings, and it displays across this meter here kind of the success of those measurements. So just a little bit of how this thing works. Okay, a few things you're going to have to gather before you start your TV-7 calibration. You need a 330k ohm resistor. The manual calls for 375, 330 works just fine for the process. You're just using it for a plate load. Half watt or more is fine. You're going to need a good quality digital multimeter, Fluke, EX Tech, something or another. You're going to need a set of reference tubes. A couple of those guys that I mentioned in the very beginning sell these, typically around $75 for a set of those. You might could twist my arm to make you a set as well. You will need a 10K potentiometer, just a small one, doesn't need to be anything big. You'll need a can of Deoxit D5 electronics cleaner, or that's the kind of cleaner I would recommend. You will need a octal tube socket, not required, but it does make the job easier, a test socket. Looks like this picture over here on the right. Pomona used to make these. You could connect your leads to them, and they stay connected while you flip this thing upside down and do calibration. Otherwise, you're trying to hold you know, your test leads down inside of a tube socket while you flip it over. It makes it really hard. And you're going to need just some basic electronic knowledge and some patience. All right, and this one we are titling How We Are Not Going to Do It, and that is by the military manual. You can go download this manual. It's easy to find. It does require some special military test equipment. You can see those in this picture here. Requires a couple different meters, and it's kind of old, obsolete stuff. You would not want to go out and buy that stuff. This manual is very long and in-depth, and although it is a good manual to have because it will help you understand a little of the background on what we're doing when we're calibrating one of these things, but that is not the way we're going to go. We're going to go with a much more abbreviated version. Okay, I realize we're 13 minutes into the video and I've not shown you how to calibrate a TV-7 tube tester yet, but I thought the background was important. These are the high-level steps we're going to take in this abbreviated approach. First thing we're going to do is we're going to do a full unit inspection. And I promise you, if you skip this step, you will fail at some point. It is a very important step. You may not fail in your first tube tester, but your third or your fifth, somewhere along the way, it's going to let you down if you don't do one of these full inspections. Certainly want to clean the unit. We're going to replace the CR101 copper oxide diode pair, and I'll show you why. We're going to test the meter. If you don't have a good meter, you're not going to have a good tube tester. There's a capacitor, or maybe 2 or 3 in here you would want to replace, but definitely one that we want to replace. Then we're going to go through and do the actual voltage calibrations. If you don't get this thing set up voltage-wise, in other words, if you're not feeding the right voltages to the right places in this tube tester, then all the little fine adjustments you do for GM calculations are never going to be right. And then finally, we're actually going to do those fine-tuning GM calibrations to get this thing calibrated against those reference tubes. So let's dive on into how we're actually going to do this. Okay, first thing you want to do, remove all the screws from the top all the way around. And you're going to lift this thing up using the filament knob on one side, and then you're going to kind of work your fingers around and get them on the other side and pull this thing completely out. You're going to want to inspect the power cord, replace it and or its grommet if needed. You're going to want to look for squished wires all the way around this thing. Right here is a great picture of a TV-7 that I had in the shop here, where somebody had closed the lid. The wire got between the case itself and the top face plate, got squished, and you can actually see here the little the metal wires on the inside there that started touching the outer case eventually and caused a problem with this unit. Inspect your wires in general all the way around. Look for anything damaged, loose, frayed, corroded, broken, whatnot. Up next, turn all your potentiometers. Feel for rough spots or broken areas, especially the bias pot. And you may want to test that thing. It should be about 3K end to end on it. Check the condition of all your switches. You can see all the switches here that are used for your kind of grid, plate, screen, filament settings. These are ceramic wafers. Make sure you don't see anything burnt anywhere. Check the 47 ohm resistors on the screen, plate, and grid gang switches. You can barely see them here, but on the sides, and they start at the top and they feed down in parallel with these gang switches, and then they connect further down in there. But there is a little 47 ohm resistor, and you can see the arrows are pointing to each one of them. Check those things well. Poke them with a screwdriver. Make sure they don't disintegrate on you or fall apart when you poke on them, because they may look just fine, but when you tap on them 1 or 2 times, they just kind of disintegrate. They're the old carbon composite resistor types. This is one of the top issues on the TV-7 tube tester. If you ever have your tube tester set on the wrong settings, when you actually apply the voltage to the tube, 1, you may damage your tube, but 2, most likely these little resistors are what go out. If you need to replace them, get some 47 ohm half watt resistors. It's a little bit of a tedious job, but see the picture I made right here? Make a hook like I did and then kind of bend that hook over at a 90-degree angle. You snip the old ones out, and you got to get some snippers with kind of a long nose to them. You can get down there and snip both sides out. You kind of hook down in there, spin your little resistor around till it hooks to connection on the bottom. Get your soldering iron down in there and solder it, and then you come up to the top and solder it in place on the top, and then kind of bend the middle part, the resistor body out away from the wafer just a little bit. Takes a little bit of time, but it's certainly something you could do yourself. And there again, I mentioned it's one of the top reasons a TV-7 tube tester may stop working. And it's a pretty cheap and easy fix as well. Visually inspect the tube sockets. Insert tubes to see if they're loose or not, especially the little 9-pin and the octal socket. They both can get some wear. You may want to consider putting a socket saver on there. Test the fuse bulb with a digital multimeter on continuity. Make sure it's good. If you happen to have another tube tester, test the 85 and 5Y3 tubes on another test. And I did make a note here about the 83 tubes. If you notice, see how this tube looks like the getter is just about all gone, and this thing looks completely worn out. Yet those things will function just fine, so don't let the looks of these 83s scare you away. All right. If you flip the thing upside down, then you will have a little plate here, and on top of it you will see here is R130, which is this big long green power resistor right here. And you're going to want to connect end to end and make sure that thing is good still. It should be about 9.5K. If this thing is bad, you're kind of toast, and you might pay a lot to get one of these because it is a critical component of the tube tester. And then you want to make sure the meter pivots are good. So flip this thing back over with everything on it, power it on, kind of hit your line test button, and make sure that your meter actually goes back to 0, and you don't have to sit there and tap on it over and over again to kind of get it to go where it needs to go. Okay, assuming all is good up to that point, then you can keep moving forward. If not, you need to address the things you found. Either, clean your tube sockets, or maybe rebend the pins in them, or if they're too bad, you may have to replace one of them. Same with potentiometers, etc. Up next, your kind of initial test you're going to want to do. You're going to want to plug in the tube tester, power it on, the pilot light should come on. You should be able to press button 1, the line adjust, and rotate the line adjust knob here on the left until the meter rests over the test mark on the meter, and then release the button. You can set the tube tester to AP00022, and if you're not familiar with how to set the thing, that would be on filament, AP, and then grid would be 0, plate would be 0, screen would be 0, cathode and suppressor would both be 2, and then you would you would take this thing and rotate the function switch through the 5 short positions. So 1, 2, 3, 4, 5. The neon lamp should glow, I should say, on positions 2 and 3, indicating the short test circuit is functioning properly. And it should not glow on the other ones. Okay, if at any point thus far you find something like, hey, my short tests don't work properly, or my potentiometer seems to be broken or have bad spots in it, or my meter doesn't work, you may need to seek professional help. This video will not go into the details on how to address all those. Okay, up next, you're going to want to clean this thing. First off, clean the face, the meter cover, you know, just the whole general outside of it. With Windex 409, something similar, whatever your trusty household cleaner is you rely on. Then you're going to want to use some deoxit D5 on all the rotary switches and pots. Work them well. Be careful if you're using a TV-7/U. Do not soak those phylonic wafers. They can start to warp. So clean, but then kind of dry off. Do not just soak those things and let them sit. Clean tube sockets with some deoxit D5. Use a small brush if you have one. My wife goes into a lot of cosmetic shops like Ulta and Sephora. If you walk in those little stores and look around, they have free little brushes that they give people for applying makeup. And I've found some of those brushes are quite handy in cleaning tube sockets and whatnot. And then clean your push button switches as well with deoxit D5, and work them all. As you clean a switch, work it back and forth 20 or 30 times. As you clean a push button switch, work it 20 or 30 times. Work them well after you've cleaned them. Okay, if you got the unit upside down, this little thing I'm pointing to right here, that is the back end right here of the push button switches. So it's all the way on one end of the tube tester, and you'll find this little thing mounted here. Some of them are gray, some of them are black. It is a CR101 part number copper oxide diode pair. And you're going to want to replace that with a modern little solid state diode setup. And I made an entire video on this topic. You can find it on my YouTube channel somewhere. So you'll use a little 3-prong terminal strip, and you'll solder these diodes in it in this direction, and then you'll connect the wires that went normally to these copper diode pair, copper oxide, black to the one end here, yellow and red, and one end 4004, 4007 diodes will work just fine. Okay, up next, we're going to test the meter in this thing to make sure it's good, because ultimately if your meter is no good, then you're going to just struggle to get this thing ever to do much of what you want it to. So I'm going to show you 2 methods here. The first one is you will either unsolder or remove, depending on the meter and the vintage of it, this little nut here, or unsolder it, the red wire. And then you'll use a digital multimeter across the tube, across where the white wire and the red wire are connected. Make sure your meter is set to read resistance or ohms, and you should get a resistance reading across these two. A perfect meter will test between 2370 and 2390 ohms. If you're much outside of that, I would proceed to method number 2. Okay, for the longer and probably more accurate route, what you're going to want to do is take both nuts off the back of the meter. Sometimes you have to unsolder these, sometimes they're just nuts on there. And go ahead and leave these disconnected. You're going to need them disconnected for the next step too. So in other words, when you finish this step, don't solder them or screw them back on. But get a 10K pot that we mentioned, put it in series with a 1.5 volt battery. It doesn't matter if the battery is exactly 1.5 volts, any AA, AAA, C, D battery, any of those will work. And what you're going to do is take a wire from the positive of the battery and hook that, like right here, to one side of the potentiometer. You could also use a power supply set to 1.5 volts if you wanted to. But you connect the positive to one side of the potentiometer. Then you're going to connect the negative around to the negative side of the meter. And then you're going to come from the positive side of the meter with some kind of jumper, like an alligator jumper wire or something. And you're going to bring that over to the center wipe on the potentiometer. Typically a potentiometer will have 3 lugs The two outer ones are typically the end to end, and then the middle one is usually the wiper or adjustable part of it. And then if you'll notice, the other side of the potentiometer here is just going to stay disconnected, and then you will connect the meter negative here around to the battery, as we mentioned. You will basically, when you do this, make sure the pot is in the middle when you start, and you're basically going to then adjust it until the meter shows full scale at 120. Then you're going to use your digital multimeter, and you're going to read the voltage drop across this potentiometer. So that would be from this point right here to this point right here, not across from one end of the pot to the other. So you'll go from the left lug that you connected here to the center tap, measure the voltage drop there with all this connected and the meter at 120, write that value down as V. Next, disconnect the battery here, or the power supply, and then flip your meter over to resistance reading instead of volts, and measure the resistance from here to here, and write that value down as R. And then we're basically going to use Ohm's law to say V divided by R, and that should give you your full scale current meter rating. This result should be around 200 microamps, because that's what this meter is rated at, plus or minus 10 microamps. That would give you a 5% tolerance. Anything more than that, you should consider replacing this meter. Okay, while you've got that meter disconnected, it is the time to do this step as well, and I'll show this as well. This is a great big capacitor that sits right above the meter on a little plate, and it's 100 microfarad at 15 working volt capacitor, and you can see the plus and minus side to it. It'll have little terminals here with the wires coming out, and these wires actually go to the meter. This is what they used to call a bathtub capacitor. It kind of looks like a bathtub. And you can replace it with any modern 100 microfarad at 15 volt or higher voltage axial capacitor. And I guess you could use a radial as well. Note the polarity. You can solder these things directly to the tabs on the meter and eliminate the wires in between them if you want. There are also two other capacitors, C102 and C104 on this unit, and you can find those kind of mounted on both sides. One's on one side and the other side's on the other side of that little plate I showed you earlier with R130. You can replace them if you wish. They're rarely bad, and they're non-polarized capacitors. So before we go any further, let's jump over to the bench and show you what we've done so far here. Okay, to orient you a little bit to the back of the TV-7, by the way, if you set it up like this, put something here underneath this transformer. It's pretty heavy, and you can kind of put weight down on these ganged switches here. But at any rate, on one end here, on the left-hand side, you've got all the push-button switches. Down bottom right here would be about where I'm pointing, about where that CR101's at. You've got all these potentiometers mounted up on this kind of bracket right here, and these are the potentiometers we'll be using to adjust the GM calibrations on this thing. And if you notice, they all have a little locking nut on the back of them that you need to loosen up before you can adjust them. And then when you're all said and done, you want to tighten them down and then check them again, because just the act of tightening these down can move your adjustments slightly. The D model has more of these potentiometers than any of the others. Some of these get into having fixed resistors in the older ones. So you actually have to swap out resistors or replace them with potentiometers to adjust them effectively. That's what makes the C and D models so popular. This is the big bathtub capacitor that we were talking about a minute ago. You can see the back of the meter here with the little nuts and the terminal connections going to them. Down in here you can see all the little gang switches, and there's 47 ohm resistors. You can see this little black wire going down right here and this little black wire right here. Those are those 47 ohm resistors we had talked about. This is that little section we mentioned where you're going to measure from one side here on the very end all the way to the other side here on the very end. And that's where you'd want to get that 9.5K. And then these are really fine little wires along here. And these wires here, you actually loosen these up and slide them one way or another. These are how you tap this resistor. So this is the same as a potentiometer. Basically, it's just a tapped power resistor. And I think that's all we will show you for right now. Let's dive into doing this meter. First things first, I have disconnected the two outer little nuts that came off of here and pulled these two leads off. If you'll notice where these leads go to, they go down to these 2 points right here on this bathtub capacitor. So I'll show you here in a second. And if you'll notice down in here, it's a little hard to see, but this is marked plus and this is marked minus. But if you're not sure, you could use a Sharpie and write on the back of your meter here just to be sure. Okay, first thing I'm doing, just making sure that I'm feeding this thing with 1.5 volts. And if you kind of look up here, way up here, I've got a B&K Precision digital power supply up there that I'm feeding down via these red wires here. That's getting me 1.496, and that's close enough for what we're trying to do here. Okay. So the wiper here, the middle little connection or tab on this potentiometer right here, see it's got 3 tabs, the middle one here, and I can grab this other one and bend it up. You can see the 2 upper and the 1 middle one. The middle one's going to the positive side of the meter here, and then the negative side of the meter here, I've hooked an alligator clip that's going over here and feeding up to my 1.5 volt source. So all that's left then is to connect this positive 1.5 to this terminal here, but I want to spin this thing around before we do that. Alright, here we go. Center wiper of this thing goes over to the positive of the meter on the back. Power supply or battery negative goes to the negative on the meter on the back. And then you've got to connect up the positive of your battery or power supply to one or the other side of this potentiometer. It really doesn't matter which. I would definitely center this potentiometer somewhere in the middle. And what you want to do is just touch this thing to one side. You don't want to latch it on. You want to touch it and see if it goes past full scale. It did. So then you're going to want to adjust this potentiometer a little bit. And you're basically going to want to get it to where it's in a place that when you're touching it, there it goes, it's not past full scale, because you don't want to latch that thing down and let it go full scale and burn out your meter. And then what you're going to do is just adjust this potentiometer ever so slightly until you get that thing set. Whoops, thing's touchy. Very, very touchy. Right there, full scale on the 120 mark. And then at that point, you're going to want to measure the voltage across these 2 points right here. We can do that just by having the meter here hooked to voltage and come over here and connect onto one side of this little thing. And then we just got to find a way to kind of connect down here onto the center point of this thing. And if you'll notice, we got 1.016 volts. And it doesn't matter whether it's minus or negative, you're just reading the voltage across let me see what that was again, I about forgot already. 1.016, I think it was. 1.016 volts, okay? Then what we're going to do is you're going to have to disconnect the power supply here completely from this little potentiometer at this point. Okay, and then what you're going to do is those exact same 2 connections, you're going to disconnect the power supply completely, go across those same 2 connections without touching this ohm meter at all here, and you're going to read over here the resistance reading, so 4.933 k ohms. Okay, and then if you remember, I is equal to V over R, and we know what V is and we know what R is here. So we should be able to then do some quick math here. 1.016 divided by 4.933, and we're going to come up with 205,959. So I is equal to 205,959. And since this was in K ohms, we're really going to be 205.959 micro amps right here. You'll notice. Did the math real quick. So 205. So this thing, instead of being 200 ohms, and if you read down in here, in this meter right down in here, it will tell you it should be 200 microamps here at full scale DC. And this thing is actually 205.959, which is not all far. You're 5%, or actually less than 5% on 200. You'd be 2.5% off here. So you're not bad at all at that point. This is really a pretty good meter, and I would say keep going with it. If this thing had been like 230 or 170, then you might want to start considering getting a new meter. Okay, up next, I've got these two little wires coming off the bathtub right here that went down to the meter. I'm going to disconnect or unsolder these two little tabs off of this, and I'm going to cut these wires, and I'm going to end up routing the two wires coming from over here down to the meter, and then we're in parallel. I'm going to solder onto each of these. Once I get them onto the meter, that's where I'm going to put that new capacitor. So just remember, the positive goes on the red wire here, or the positive and the negative. It needs to be 100 microfarad, 15 working volts or more. It could be 100 microfarad at 100 volts. As long as it physically fits, you'll be fine. Okay, you can kind of see what I've done now. I removed these two pieces of wire here that were going from the bathtub down to this, and I took the red wire that was going to the bathtub and the white wire here, and I just ran them down and soldered them to the two tabs that I had put back on here. And then as well to that tab, I soldered my 100 microfarad capacitor here, and this happens to be a little Sprague 100 microfarad at 100 volts. And I made sure I've got the positive here on the positive side and the negative on the negative side, and that should help things out. Those bathtub capacitors, when they're leaky, they cause your meter to move very slowly instead of kind of crisply up to the point that it's trying to read. You can also see here how I used a little 3-terminal strip with just a little connection on one end here, and connected it to the place the other diode bridge was connected, soldered two 1N4007s in series, and then connected my red, yellow, and black wires as they should be to each of these three connections. Okay, so you should have done a good visual and inspection of the unit, cleaning of it, make sure everything was in order. So now we're ready for to start the calibration process. First thing you want to do is turn this tester on, leave it on for a good 15 minutes. And I'm going to walk you through these here on the PowerPoint, and then I'll take you over and show you how to actually do this. So let the tester warm up for a good 15 minutes. Set the tube tester like you were doing for a 6L6, which is HS53481. And then it would be a bias of 23 and range D, but those really won't matter. And then do not install, I repeat, do not install a tube into the octal socket. Do not put a 6L6 tube in there. But if you do have a tube socket test adapter like I'd shown you earlier, it's a great time to make sure you've got that inserted. By the way, do that before you power the unit on, because you do actually have voltage on those little pins as you're inserting that thing. You're going to want to set the filament to 10 volts. I know for a 6L6 you would not put it on 10 volt filament, but we're going to do that because 10 volts is kind of in the middle of the range of all the filament settings on this thing. So if you can get the 10 volt setting right on this, kind of the other two ends will follow suit. Put your digital multimeter on AC volts, connect across pins 2 and 7. If you're using the socket adapter, that's easy. You clip the two leads on there. If not, you're going to have to use some kind of little leads that have protruding metal ends to them that you can stick down inside the pin sockets. And you're going to have to hold those in there while you adjust things, which is a little bit of a pain. And what you should be looking for is 10.3 volts to 10.12 volts RMS across pins 2 and 7, and make sure that's on AC volts when you do that. And you're going to adjust R134 until this is true. So I'll show you here more in the video, but you're not actually adjusting this voltage. What you're adjusting is where the line set is at. And if you adjust the line set to the left, then it takes more voltage to bring it up to the proper point, and thus you increase the voltage to the pins of these tubes. And you will be using R134. Just to note, some older models use fixed resistors. One thing I will say is I'm teaching you about the TV-7 here, but this can apply to the TV-2, 3, a lot of these different units, the TV-10. If you can get where you can calibrate this one, you can probably calibrate the others by following the instructions for them. But some of the older ones have fixed resistors, so it's a little more of a pain. You could substitute with a pot, kind of turn it, get it where you want it, then figure out what fixed resistor to put back in there. And I noted here some people also test at 0.6 volts and 117 volts, the two ends of the filament scale, and just making sure that those are somewhat in range. It's kind of you can kind of adjust to get the 0.6 perfect, and then your 10.03 to 10.12 will be off a little bit, and then you swing it over to 117, you adjust to get it perfect, and then the both the 10 volt and the 0.6 volt are off a little bit. It's because this is not a highly precision device, but that's why we usually try to adjust around the 10.3. You're getting close enough. Okay, I've got the unit on the bench, and I was getting ready to show you how to do the calibrations we just walked through. But unfortunately, I've found another issue with this TV-7 that we're going to have to address first. And it's a pretty common problem with these things. I want you to watch this. One of the things we're supposed to do is hit this line adjust button here while turning the line adjust over here. And you're supposed to get that thing up on 60. Well, watch this meter. As I thump it, it goes up there. So if this thing was out of whack and it's sitting right here and you're trying to get it to go up to 60, you would turn it and let's see, get it along in here, but then you thump this meter and you bring it back and it's not on 60. And what this is called is a sticky meter pivot inside, and these things over time just get kind of worn out. Watch this as I thump it and bring it back. Now look where it's at. You have to thump the thing to get it to go where it's supposed to go. Now over time that becomes extremely frustrating as you're trying to use a unit, because you're trying to do your line adjust. Okay, I think I got it right there on 60, and then you kind of bring it back and it's sitting there on 60, but then you thump it a couple times and oh, it's not on 60, it's up there on 68. So you bring it back down here on 60, and then you go to use it again, and wow, it's sitting down here at 52. The pivots are sticky, holding this meter from working properly. Okay, to remove the meter, all I did was used a wing nut here, a nut driver, and pulled that off, and then took the two nuts off, and then this capacitor with the two little leads on it just lifts right off, and I've kind of got it out of the way now. And I have unplugged this thing just in case you're wondering. You would not want to be working on this with it plugged in. And then what you're going to want to use is a really good screwdriver as you go to take out this meter, because these little screws right here, if you booger them up, you're going to reuse these screws when you put the new meter in. So make sure you use the right size screwdriver, not something too small, or don't try to cram something in there too big. And that's all there is to taking this meter out of the unit, and then we're going to drop an entirely new replacement unit in it. Okay, we've got the meter out of this unit at this point in time, which was this one, and this is the replacement meter that we're going to be putting into it. If you'll notice, they are, let me zoom in here, maybe you can see it, but this is part number 300-4357. And if you read the little bitty writing down here, it's 300-4357. This just happens to be a revision C, which is a newer meter than this one was. But internally, electrically, the exact same meter. Both 200 microamps on these to full scale, as well as both the internal same internal resistance. One thing I would say about these sticky pivots, I have before, and I've read stories and talked to others where you can take the cover off and kind of remove this acrylic housing, and you get down inside here and you want to blow out with some canned air or something very gently, just to make sure there's no dust or debris that has gotten inside of the magnet in there, because what you've got is a coil attached to the needle, and down in there is a magnetic frame that it's in, and if you get a piece of debris in there, it could cause the sticky meter issue. Or if you get dust, but the likelihood of getting dust or debris inside of one of these, when you've only got 1, 2, 3, 4, 5, you've only got 10 screws holding this thing together. Pretty darn slim, to be honest. The other thing, there's a little small set screw in there you can try adjusting, that is the tension on the meter pivots. But what I have found, and even other people that restore these types of testers has found, is you can try messing with that stuff. A lot of times you end up, the meter just doesn't work as it should. Other times you think you got it kind of working for a minute, and then a day or a week later it kind of creeps back in there and has the same problem again. And it's just the pivots are kind of worn out, and turns into a kind of a warranty maintenance issue for somebody like me repairing it. Even if I thought I had it fixed, it's not as not something I would put my name behind and say, yeah, I'll warranty that for a period of time or whatever. So it's better to get a new one. You got a couple choices. You can find a good working used one like this. This one's practically new, it looks like. Or there's some aftermarket remanufactured ones you can pick up out there as well. So either route, let's get this one mounted into the hole. Just put the 3 screws back in here and we'll get started from there. As you can see here, we've got the new meter mounted back in. Make sure that the red wire is on the plus side and the white is on the negative. Got your 100 microfarad capacitor across here, and we're going to flip this thing over and get back to calibration. Okay, if you'll remember, HS53481, and I've got to let this unit warm up for about 15 minutes, but I thought while we were waiting on it to warm up, I would show you how a proper meter should work. So I've got it kind of zeroed in over here on the 0, or on the very left tick. And when I push this thing, it goes to 60. And when I let off, it goes down. And when I push it, it goes to 60. You notice how much cleaner this is than the one that we had in there earlier. This thing seems to be going back to the same spots every time, which is what you want out of your meter. Okay, up next, you notice I've got our little socket adapter here. And on pins 2 and 7 here, I've got a multimeter leads connected over to a voltmeter that is set on, so we can get it back here in a good spot. It's set on volts AC, so right now we've got 9.66 volts AC across this thing. I also have this set, like we talked about in the video, on the 10 volt scale. And what you want to do at this point is, let me back up just a little bit. There we go. You want to push this meter and adjust until your line test is dead set in the middle right there. And then you want to read your voltage over here on the digital multimeter. And if you'll notice, I'm at 9.66 volts across 2 and 7, and I've let the unit warm up now for 15 minutes or so. And if you remember, this should be at 10.03 to 10.12. So we've now got to adjust R134 until that is actually true. So we're actually going to spin this unit around. That's why I like to keep it on a like a little this happens to just be something I bought at a home goods store, where it's a cutting board, a Teflon cutting board, but it makes it easy to spin around. And right here is R134. So you got R136, I think it is, R134, R115. And this is the one you're going to want to adjust. So you're going to want to make sure you unlock the lock nut on the outside of it first. And keep in mind, there are high voltages flowing through this whole back side of this thing at this point. So you're going to want to be very careful. Use a screwdriver that has a good plastic handle of some sort that would insulate you. And I'll show you how we're going to adjust this. I'll kind of do my best here to show you what's going on. But if you notice, I've got my hand back here, and it's a screwdriver. It's inserted into R134, and I'm going to push the button, which is right down here, the line adjust button, and you're going to watch this scale go up to 60. Well, what this R134 adjusts is not the voltage to these pins over here of the socket. What it adjusts is where your line set is relative to the voltage being applied to this thing. So let me give you an example here. If I push the line test button, and let me spin this around so you can see it well. Right now it's on 60, but if I turn this thing a little bit, it'll go one way or the other. And because I'm below on the voltage, I'm at 9.68, I'm actually going to want to take this thing over this way down. In other words, now as I adjust the, let me zoom back out here. As I adjust this little potentiometer down here, the line adjust on my left hand upwards to get that thing at 60. Now you kind of flip over here and notice what's happened. We've came up in voltage now to 10.07 volts, which is right in the middle of the spec of where we want to be, 10.087 9. We're in a good place. So all I did was turn R134 until the needle moved this way, which means it takes more voltage then to bring it back to 60, and that increasing voltage down then also raises this up. If you do it a few times, you'll kind of see what I'm talking about. Just grab a hold of R134 back there with a screwdriver, adjust it. You'll see it's playing with the line test setting, not necessarily this setting, but in adjusting all that, you increase the voltage here till you get it right. Okay, if you'll notice, we're still here at 10.06, 10.07. I'm going to adjust this now down to the 0.6 range. And you'll notice we're at 0.654, which is pretty darn spot on. And then if we take it all the way over here to 117 volts, whoops, you notice we're at 117.9. You could adjust it to get it exactly on 117. But then your 10 might be down just a little bit. It's kind of one of those, this full scale accuracy of this whole thing. They're not, you know, high precision devices. So I think getting it in the middle here in that range is about as good as you're going to get it, unless it's just way off on one end or the other. And I would leave it at this. As with most things around here at Blue Glow Electronics, the further in we get, the more the plot thickens, and so I got ready to do the next stage of calibration on this thing, and ran into a little bit of a problem. So what I've got going on right now is, you can't really see it well, but right down in here is the bias pot, and I've got this connected to the center wiper of the bias pot, and I've got this connected to a little lead right here, but this red wire right here that's connected to this lead goes straight over to one of the outer wipers on that. It's easier than getting both of these leads down in there, but in essence I've got it on two of the center and one of the outer wipers on this bias pot. Okay, and watch what's happening here. And I warned you about this earlier. It should be about 3K end to end on this bias pot. But watch this thing. I'm way down here at kind of, you know, 1 ohms, 2 ohms, 10 ohms, 30, 40, 50. I'm just going to slowly take it here. 100 ohms, 150, 200, 300. This thing does pretty good until you get up a little up. Okay, it switched over there. I was at 600K. It switched from 600 ohms to 0.6K ohms is all that happened there. So we keep climbing 0.8. So we're at about a kilo ohm here almost. 900 ohms. Kilo ohm. Alright, we're over here at about 55 now. Watch this thing. Instantly it goes to open link here at 55. So basically what's happening is the wiper has moved beyond a point in this wire wound potentiometer where there's an open wire. In other words, this thing is swung to the other side of the opening now, and there is no connectivity from here on over the rest of the way. So this bias pot has an open in it in the winding, and there it goes. As soon as I cross back over, you can see the other side. Let me show you how this would look. There we go. So the way this would be is you've kind of got your center tap and then your two end lugs, and so if you connect it here and here, you can see wherever the wiper would be as it's moving here along this coil of wires. You know, the resistance is changing because this is like a wire wound resistor here. But at some point, if the wire is broke, you're good connectivity from here to here. But as soon as you jump to the other side of that broken wire, no longer do you have connectivity back. And that's actually what we're seeing over here. As soon as I get over a little bit over the 1.1K range, this pot is opened up. So you're never going to get this tester to bias properly in this state. So unfortunately, you can't just go out and buy a 3K pot and drop it in here. It is not logarithmic and it is not linear. In other words, an even swipe from one end to the other, nor is it logarithmic. It is a taper pot that was custom made for these TV-7 tube testers. And so all the sources of vintage ones have about dried up at this point. Fortunately, Daniel Nelson had a had a run of these made, and I don't know what they cost him, but he charges $75 plus $5 shipping, so $80 for one of these. But fortunately, they are available. Otherwise, your tube tester is basically toast. So I ordered this from Daniel here last week and just got it in today. So to remove these things, you're going to first get off the chicken head knob by removing the little set screw on these things. These things can be a little bit of a pain to get off at that point. But we'll get it off. We'll get the lock washer off on this side, and then we'll have to end up unsoldering this thing on the back side to get it out. Please note there is a lock screw both on the back here and on the top of these chicken heads. So once you get both of those off, that thing comes right off, and then that looks like about a 9/16. We'll get that off. Alright, got the screw off here, or nut, and then this thing will start to push out the back. We'll flip it over. Alright, you're then going to want to get the 83 tube out of this thing. We'll push on this little tube lock here, and then you can slowly work your tube out there, and then that gives you a lot more access room-wise to get in down here and kind of desolder the wires. So just get you a piece of paper, draw a picture of the potentiometer, and mark what color wires go where, and unsolder that thing. Okay, once you get the everything kind of written down on a piece of paper here so you know how it goes back, then you're going to want to take loose these 3 screws right here on the front. And use a good screwdriver because these screws are painted, and you just want to make sure that when you get them, you don't end up marring or scratching the paint. But those 3 will come out, and what they actually do is they hold this whole frame right here in place. And you're going to have to be able to move it back a little bit to be able to get the bias pot out. As you can see down in here, it'll only lift up so far with this bracket right here in the way. Okay, you can see here now, once you get those 3 screws out, this whole part right here moves, and it gives you just enough room to get down in here and kind of push the bias pot like this. And then you can bring this thing out here, where it is much easier to solder and unsolder than way up in there. Okay, as you can see, we got it all soldered back on now, ready to kind of mount this thing back in there. Okay, we've got the nut and washer back on this thing. One thing to note, when you come through from the other side, this thing does have a little divot on it here, and in the back of this faceplate here, there's a little divot, so it goes in the right place, so you can't go into the meter this way or this way. It's got to be just right. So get the divot first, get in here, tighten it up. Now I'm in the middle of putting these 3 screws that hold that one bracket back together, and then we'll put the chicken head back on it. When it comes to putting the chicken head back on, just turn this all the way over to the left, and then get this thing on here and align it up on 0, and then tighten the set screws down. Okay, got the same 2 leads connected back the way I had them before. This is the way this pot should work. Climbs up to 100, 2, 3, 4. Okay, then it switched over to 0.7, 0.9. Okay, we're at 1 kilo ohms. 1.1, 1.2. So we never made it this far before. 1.5, 7, 8, 9, 2, 2, 1, 3, 5, 7, 8, 9, and that's as far as it goes. 2.943K. So that should be how your pot should work. Let's get back to calibration now. Okay, we're going to set the grid voltage settings on the unit at this point. First thing you want to do is make sure when you turn your bias pot all the way to the left that the knob is actually pointing at the 0, exactly 0. If it's up and pointing at, say, 6 or 10, or it goes past the 0 to the left, you're going to want to adjust the actual chicken head knob so that all the way turned to the left is at 0 before we get started. Then you're going to want to connect the negative lead of a digital multimeter to the center tap of R110. So this little resistor right here on the back side of this board, it has 3 sections to it, a center tap here. You can either connect your negative lead here, or you can connect it to pin 8 of the octal socket, either one. They're the same connection point. You're going to want to connect your positive digital multimeter lead to pin 5 of the octal socket, and then put your meter on DC volts. And you should have somewhere between 2.3 and 3.2 volts reading on your meter, or it may be negative 2.3, 3.2 volts. When the bias is set to 22, and then if you turn it all the way over to 100, you should have around 40 volts. If not, you're going to want to come over here and you're going to want to adjust slider number 2 on this thing. So this is this very end one right here that I'm pointing, that the orange arrow is pointing to. You're going to want to adjust it, and be careful. This is a wire round resistor. Make sure you loosen that thing up good before you go sliding it one way or another. But you're going to want to get it so that the voltage there at 20, when the bias is on 22, is between this range. Okay, first thing you're going to want to do here, make sure your tube tester is warmed up for a good 15 minutes. And you're going to want, you notice I've got it on pin 5 and 8, and it's showing minus 3.2 volts, which, hey, that's not far off from what it says. But first thing you're going to want to do is make sure your line voltage is set properly. Okay, we've got the line set right there, and look, now we're at minus 3.39 volts here. So we're going to have to adjust that little slide until we get this within between 2.3 and 3.3 here, or 3.2. Okay, I recommend turning the unit off and completely unplugging it. You do not want to do this live. So first and foremost, sometimes up here between this very top band and the end lug right here will be a little wire in here, and you'll need to come snip that little wire. This one doesn't have the wire there, but a lot of times you will actually see a little wire jumping between these two that's soldered. If that's the case on yours, if it is, snip it. You want to get rid of that. And then up next, what you're going to do here is adjust this thing, and all I'm going to do is slide it one way, turn this whole thing back on, and see if I'm any closer. And if I went the wrong way, then I'll unplug it, adjust this back the other direction, plug it back in, and see. Okay, if you'll notice now, I've slid this thing down. I've adjusted it twice now to get it into the range. But remember, we're supposed to be between minus 2.3 to 3.2, and we're at 3.0 here. So that puts us in a good place. You just got to be careful when you loosen this thing and you're adjusting it. Make sure you loosen it enough that you're not dragging the little bead that sticks in there across the wires, because you can easily break them. You want this thing to slide really easily when you're moving it, so make sure you loosen it up enough for that. So I'm going to get this one tightened down good now that I know we're in the right spot, and we're going to go from here. Alright, let's move on to setting the high voltage screen setting. And what you want to do is, with the power disconnected, you want to check out R130 right here, and if down here on the end, see where my test lead is connected to, there is a jumper between this very end of the potentiometer and this first movable point right here. You're going to want to snip that little jumper if it's still in there. Up next, you're going to want to connect a 330k ohm resistor between pins 4 and 8 of the octal socket, and I can show you a neat way to do that. I know the original military manual said 375k, but this 330 works just fine. Power the unit on, turn your bias all the way to 0. Connect the negative lead of your digital multimeter to either the center tap right here of this R110 or pin 8 of the octal socket, and then connect the positive of your multimeter to pin 4 of the octal socket. And then you're going to want to basically adjust this very first little slider right here, slider tap on R130, until you get 130 volts on your multimeter. And to actually get the 130 volts, you must push button 3. In other words, the screen voltage doesn't get applied until you push button number 3, mutual conductance, to actually activate that. So you would hold in that button, see if you have 130 volts. If you don't, you'd come over here and adjust this until you get close enough. And I'll tell you, 130 volts, 131 volts, 129, anywhere right in there is good enough. Let's go do it. Okay, we're now connected to pin 8 and pin 4 here. And I happen to know this one's already got that wire snipped. So the next thing up with the unit powered off is to connect between pins 4 and 8 a 330 ohm resistor. Well, I do enough of these things that I've just taken a, you can order these online, just a empty socket tube base. And basically then all I've done is soldered into it a 330 ohm resistor right here between pins 4 and 8. So then it's just a matter of kind of plugging that in, and hopefully you can start to see the value of having one of these Pomona test sockets here where you just kind of clip onto. Now I've got the resistor in there. It makes it easy. If you're trying to hold digital multimeter leads inside these tube sockets, it's a little bit of a pain. So basically, let me power this thing on now at this point. And you can see here where we're talking about on this, see on the upper end here, mine's already had the wire snipped, or this one has. And what you're going to want to do is hit button 3 here. And if you'll notice, we're at 131 volts. So I'm going to try to adjust this thing just a little bit, this top one. I am going to unplug the unit to do that. I'm going to move it just down just a little bit, tighten it back up, then plug the thing back in, and we'll see where we're at. Okay, we moved it down just a little ways and power this thing back up. And whoa, I'm way off. So I got to move that thing back up that direction. Okay, after about 10 minutes of trial and error here, if you'll notice, I got this thing 130. It's right there on it. That's as close as I'm going to get. And you can see it's pretty far up on the end there. So sometimes you have to snip that thing to be able to slide it down to get to the right voltage you need. But I think we're going to leave it alone right here. Okay, at this point we're going to want to do what is called the low screen setting. And you're basically going to leave everything the way it was. Pin 8, pin 4, you're going to leave your resistor and all the settings intact. You're going to want to push button 2 and 3, the diode button and mutual conductance button at the same time. And you're going to get, you should get about 56 volts. If not, you're going to want to adjust now this little setting right here, the middle tap, until you get 56 volts with both 2 and 3 pushed together. Okay, as you can see now on 3 I've got 129.6. I did just a little bit more adjusting. It kept climbing up as the unit warmed up a little bit, but I'm going to leave it right along in there. And then if you push buttons 2 and 3 together, 67.3, and that needs to be down at 56 volts. So I've got to adjust this middle one right here now to get to 56 volts. So I'm certainly going to unplug that unit like I just did, and I'll get my trusty little precision screwdriver out here, and I will start adjusting this thing. So you want to get them good and loose until you can slide that thing. Let's slide it right there and tighten it down just a little bit. And then you can kind of watch what I'm doing here. I'll plug it back in, and we'll push buttons 2 and 3 together. Whoops, we're going the wrong way. We've got 78 volts, so we got to take this thing downward. Unplug it again, and I'll keep going until I get it right. Okay, after about 8 attempts here, I'm at 56.65. It's close enough. I'm going to leave this thing alone right here. Okay, one thing I will tell you is if you don't get these voltages fairly close in line, you will never get one of these things calibrated. So it's all about getting the screen and grid voltages. We've already done the line of adjust voltage. Now we will move on to the actual calibration tubes and the settings around those that will all revolve around these potentiometers right here. Okay, it actually gets pretty easy from here and goes pretty fast from here. First thing you want to do is you're going to want to set your range switch over to 5. So not A, B, C, D, E. Take this thing over to 5. Do your line set adjustments. So, push button 1 and do your line adjust knob till you're at 60. You're going to want to loosen the lock nuts on R113 and 115. So R13's one is right here, and R115 is right down here. And you're going to want to measure across it with an ohm meter. Make sure your unit's unplugged at this point. And you're going to want to try to adjust for about 41 ohms. And you may wonder, well, which of the 3 leads do I connect to? Well, only 2 of them have wires on them, so hook to the 2 that have wires connected to them. first you're going to adjust R115 for about 41 ohms. It doesn't have to be exact. It could be 42, 43, just right in that range. And you're going to want to do the same then for R115 down here. Adjust it and get it for 41 ohms. All that you're doing right here is making sure that you're somewhere within the range of the calibrations for this tube when you start out, so you're not completely off scale. Then what you're going to want to do is kind of remove your ohm meter from that, set your tester to a 6AU6, which is settings ET15672, bias 16 range B. Insert your calibration tube, let it warm up for a good 5 or 10 minutes. Do your line adjust again. Remember, every time you insert a tube, you need to do your line adjust, because the filament of the tube will pull down the voltage just a little bit, and you'll want to adjust that upwards till it's right. And then you're going to push mutual conductance button, and you're going to want to adjust R113, this top one right here, until the meter on the front matches the number that is written on your calibration tube. And at that point, you will have adjusted for the range B 6AU6 tube. First things first, the two leads here are two terminals with the wires on them. I've got my multimeter hook here hooked to. I've got 42.2 ohms, and we're just going to adjust this little thing. You do want to loosen the lock washer here first. We're just going to adjust this thing until we get it down to 41 ohms. Spot on, right there. Close enough. Let's move over now and do R115. Same story here. They've got this thing 42. Oh, I'm going the wrong way. 41.0. That's close enough. Okay, if your set of calibration tubes from Daniel Nelson, you can see I got these from him years ago. This is what comes in the box. You'll get a 12AT7, you'll get this 6AU6, and you will get a 6L6 test tube. And each one of them, both written, it'll tell you right here, 86 is the value we're chasing on this thing. And it'll tell you ET15672 range B bias 16. So we're actually going to get this thing in here and get it set up and test this tube and see what it turns out to be. Okay, at this point I've removed my test socket out of the way. I've also disconnected my multimeter completely, and I've got this thing on 6.3 volt filament, ET15672 range B here. First thing we're going to do is want to do our line adjust, and if you notice it's just a little bit to the left. We're going to turn that over, and we're going to let this tube just warm up for a little while, but if you'll notice right now, I'm getting a reading here of 98, and this thing is supposed to be on 86. So you can see it's pretty far out of calibration at this point in time. And now it's just a matter of check my line voltage, it's good, and then hit mutual conductance. And we're going to adjust this thing down till it's 86. Keep in mind, each little tick, like that's 80, that's 82, 84, 86, right there, spot on. Alright, so up next we're going to set the tube tester up for a 6L6, 6.3 volt filament, HS53481, bias 23, range D. Insert your 6L6 calibration tube, let it warm up a good 5 to 10 minutes. Perform your line set adjustment again, button 1 in the live non-adjust knob. Press button 3 and then adjust R115 until the meter matches the calibration tube. And then go back and do the 6AU6 and the 6L6 just one more time to make sure they're both on. Sometimes adjusting one can pull the other just a little bit off, so make sure you get them set properly. Okay, up next we've got our 6L6 test tube, and it's got a 43 is the range that it should be calibrated to. The good thing about these old metal 6L6 is a lot of guys don't like to run them because they just don't look as good in an amp as a glass tube, but these things are perfect for calibration tubes. So we're going to go 6.3 volts, then we got to go HS5, 3, 4, 8, and 1, and then we want to get this thing on range D down here, and we want to go to a bias of 23 right along in here, and let's get this tube in and get it warming up, and we'll be back in just about 5 or 10 minutes once it's warmed up. First things first, do the line adjust, and there we go. And then check the mutual conductance. We're at 40, and it's supposed to be on, according to this, 43. So let's get it on R115 and adjust it. Here we go, and we're going to get it up to 42, 43, right there in the middle. Spot on. All right, at this point, I always go back then and do the 6AU6 tube again and the 6L6 tube again. For a couple of reasons. One, I have adjusted these before, and I thought I had it on 26 or 43, but actually I was sitting on 53. And so you just want to double check yourself, and so I always go back and do them again just to double check. As well as you may have had something out of whack along the way. Maybe you didn't have the bias exactly right or line adjust or something. So check them twice before moving on. Okay, on this next one, what we're going to do is adjust range C. It's a little unorthodox what we're doing here, but it works. So leave everything intact from the previous 6L6, including the tube. Set the range on B and adjust the bias so that when you push the mutual conductance button, the reading on the meter is 120 full scale. And then you're going to want to switch over to range C, and you're going to want to adjust R114 until the meter reads exactly 60 in the midpoint. And you may want to go back and forth between those two, just checking it a couple times as needed. Let's go follow along. Okay, we've got the tube still left in. All I did was reach over and flip this to range B. Hit mutual conductance. If you notice, this thing pegs out over here. And what you're going to want to do is turn the bias up to about 50. And if you'll notice, it's no longer pegged. And you're going to want to adjust this bias downward then till this thing is spot on 120 right here. Then what you're going to do is flip over to range C and hit this button, and you're going to now go adjust the potentiometer until this thing is spot on 60. Okay, R114 is this bottom one down here, so we'll get a screwdriver in it and get this thing spun around and adjust it till it's right on 60. Okay, we got a screwdriver on there. Now we're going to hit the mutual conductance button, and we're going to just adjust this thing until it is right there, spot on 60. Then what you're going to want to do is flip back to B and make sure that thing's on 120. Flip it back here, make sure it's on 60. Off just a little bit. I'm going to adjust it just a little bit more. Okay, we finally got it here on 60 on C, and then we're back over there, and it's working out just fine. Okay, at this point we've got the 12AT7, which is you can pick one side or the other, doesn't matter. 12.6 volt filament EV7 6080. Should test at an 84. And theoretically, the setting we just did a minute ago, where we got this thing set at 120 on B and then switched over to halfway on C, should have gotten this thing calibrated on this this tube. So first thing you want to do is your line set, and then look. We're not quite at 80, and this thing's supposed to be 84. So we're going to go adjust R114 to get it to 84, because this will be more accurate than the kind of the old manual style that we just did a minute ago. One thing I've learned over the years, if you're working on one of these and your potentiometer your needle seems to jump around a little bit as you're turning the potentiometer, you might want to grab the pot and just work it back and forth some, and kind of clean up any of the oxidation or whatever may be in there. You can even take the cover off and put some deoxit in these things if you want to. But that'll help you in trying to adjust these things, you know, spot on to where you're trying to get it to. So right there, look, it's moving much smoother now, and it's dead on 84 right there. Okay, spot on at this point. Okay, similar to what we did earlier. Put your 6L6 back in, set everything up for it, let it warm up a few minutes, do your line adjust, push mutual conductance, and adjust your bias meter until the meter reads 40. So normally the bias is on 23 for this setting. You're going to want to just adjust that until the meter is reading 40. Then you're going to want to change over to range E, and this meter should be reading about half of that, between 20 and 22 or so. Okay, everything's set up for 6L6. Do your line voltage adjust right here. Then what you're going to want to do is push mutual conductance. And if you'll notice, with this thing on 23, it's set on 43, which is what it's supposed to be. But you're going to want to adjust your bias meter until this thing is dead on 40 right here, right? Then you're going to want to flip to range E, push mutual conductance again, and look, it's right there between 20 and 22. If for some reason it's not, then your voltages somewhere are out of whack. So you're going to want to go all the way back to the beginning, check the line voltage, the grid voltage, your screen voltages, and come back through this thing. Same with the previous one where we did the full scale at 120 and then measured at 60. And last but not least, we're going to calibrate range F here. So you're going to remove 6L6, the tube, from the socket. So take it out of the tester. Set everything up though like you're going to test a 6L6, but make sure you put it on range F. Do your line set adjustment, and then just turn the bias meter over to 75. At that point, you're going to want to adjust R139 for 2.7 volts DC across pins 8 and 5 on the octal socket. You're basically setting the DC bias voltage here on this thing. Let's go see how this is done. Okay, we've put our little test socket back in here so we can clip leads 5 and 8. We've set everything up just like a 6L6, except for we put the bias setting over here on 75 like it told us to. We did our little line adjust, it's on, and at this point then we're going to measure the voltage across those two, and I'm at 2.70405 volts, and I'll be honest, I'm not going to adjust R139, I think it is. Yep, R139, because I think this one's already spot on. This is the only calibration setting that's actually been on the whole time. But if you spin this thing around, this very top one up here is R139. And so we could adjust it if we needed to, but fortunately in this case we don't have to. Okay, congratulations. At this point, your TV-7 tube tester is fully calibrated. And so a couple things you're going to want to do. Tighten down all the lock nuts on the potentiometers. Sometimes just the act of tightening those down can move them just a little bit. So you may need to recalibrate just a little bit. Make sure all the screws to all your sockets going around the faceplate are tightened down, and any other screws on the faceplate. If you have tube socket savers in your tubes, make sure they're all tightened down good. Make sure when you're dropping this cover back down, the unit back down into the cover, make sure not to pinch wires. Matter of fact, I found a pinched wire on this one. I'll show you here in a minute. Somewhere on the unit, make you a calibration sticker and put it on there. It says, hey, I've calibrated this thing, and put the date. And then, enjoy your new service calibrated TV-7 tube tester. You can also make another set of calibration tubes, pass them along to a friend that has a TV-7, point them to this video, and they should be good to go. Keep in mind, if you have something besides a TV-7 DU, some of the older ones, a little bit tougher to adjust some of these potentiometers because they're fixed resistors. But the same concept applies to what we did here today to a lot of Hickok style tube testers. And then just some reference material I'll leave in this video, the tube tester page I mentioned earlier. This is a link to a tube data spreadsheet that has lots of modern tubes that weren't in the original manuals. And similarly, there's a set of manuals, such as service manuals and whatnot, out on this website. Okay, at this point I've just used a 1/2 inch socket here, and I've gone through and I've tightened all these lock washers up really good. Made sure all the screws here are good and tight on this thing. You need to go around and look for any pinched wires, and let me show you here exactly what I'm talking about. This unit actually has one. I guess they were either done this way a lot from the factory, or maybe even but you can see this one as it was closed. Right there is where it sat, and then when this thing dropped down inside the chassis, you can see how flattened this thing got. So I'm going to have to get that wire out of the way so that when the lip of the chassis comes down in here, it doesn't pinch a wire. One last thing I'm going to do on this one, mainly because the cord's not too bad. it was all moldy when I got it, but it's actually pretty flexible. But one of the issues is this little grommet here is just shot and it keeps popping out, and I tried putting a strip tie around the back of it, but even that, it keeps popping out. So we're going to replace this with a modern 3-prong cord instead of this. Okay, a couple options you've got here. You got to get the black wire here off of this end of the power switch, and the white wire here goes to the middle of this potentiometer, which you can match up on a standard old power cord here. I'm going to cut the end off this IAC cord here and just use it. You also need a new strain relief, because this older one is typically for a much larger cord. It's a Heiko 11.2 or Daniel Nelson will sell you one of these. And you can just kind of route it back in then and get it all set up. And you can either just kind of go with the hot and the neutral, or if you want, you can put a third lug on there for the ground and bring it over here and tie it off to the edge of one of these tube socket that would ground it to the chassis. And as you can see here, just got a new cord ran through here. We'll end up crimping this on here shortly. Got the white, the black. You just put the black back where this one came from, the white where this one came from, and I'm going to tag the ground down here on this little bitty bolt right here attaching to the tube socket. Okay, you have to route the cable in behind, the power cord in behind these leads right here, coming to the power transformer. I've got the white soldered in up here, I've got the black soldered on here, and I was getting ready to solder the green on. If you'll notice, I took this nut loose right here, and I've just put a chassis tag here so that it gives me something to come down here and solder to. No different than what you would use on a, so I can zoom in on it a little bit. You can get a view of it here. Yeah, right here. Just a little chassis tag, and grounded it underneath that nut right there. Alright, we got the new strain relief locked down in here, got it soldered up, got the tag soldered down. Should be good to go. Gonna put this thing back in the chassis now. Now I'm just doing some cosmetic cleanup. I like to use this Mr. Clean with Febreze. This thing had a lot of up underneath in here, kind of mold and stuff in here. And I'm just trying to get it all cleaned off good for the customer. You know, I always believe in when you restore something, the physical aspect's just as important as or the cosmetic aspect just as important as the electrical aspect. So we'll get this sorted out and get it back in. Alright, we've got the unit all back together, got the screws back in it, got the top part cleaned up a little bit. Do a line bolt stitch test here, spot on. And we're still spot on at 43. I always like to put a tube back in it, just test everything. Just the act of putting this all back together, you could bump something or knock it off. So at this point, really all we have left is to actually come along here and peel off our little calibration sticker that we've made. And I typically put these things about right along in here. And got it on there, it's marked, it says calibrated, it's got the date 1/2018, and we're going to get this thing back to the rightful owner at this point. Sorry for the 1.5 hour long video. It's just if you wanted a step-by-step with in-depth explanation along the way, that's kind of what it took on this thing. Just so you know, calibrating one of these things is not a 30-minute venture, it's a couple-hour job. You probably get it a little faster if you get good at them, but your first time out of the gate, plan to spend a couple hours doing this. Thanks for watching, everybody, and we'll keep them coming.